Hello once again students. After the discussion of gears, now we are going to study about gear trains. Now let us start. What is gear train? Gear train is the combination of gears used to transmit motion from one shaft to another shaft. This is the figure of a gear train. It consists of gear 1, gear 2 and gear 3. Gear 1 is in mesh with gear 2 and gear 2 is in mesh with gear 3. This is the gear train. Now, driver. Driver is the gear which drives the other gear in a gear train. And driven. Driven is the gear which is powered by the driver. Now, intermediate gears. The intermediate gears are those gears which are in between the driver and driven. And now, the term pinion. What is pinion? In a pair of gear, the smaller gear is called pinion. Now, let us understand these terms with the help of figure. In this figure, gear 1 is in mesh with 2 and 2 is in mesh with 3, and gear 1 gives its motion to gear 2 and thus in turn it gives its motion to gear 3. So, gear 1 is called driver and gear 3 is called driven, and the gear that is in between the gear 1 and 2 is called intermediate gear. And now, the pinion. In this gear train, we have two pair of gear. The one pair is formed between gear 1 and 2 and the other pair is formed between gear 2 and 3. In this first pair, the smaller gear is gear 1. So, this is called pinion, and in the second pair of gear that is formed between gear 2 and 3, the smaller gear is 3 gear, gear number 3. So, this gear is called pinion for this pair. Now, terms related to gear. There are some important terms related to gear. The first one is gear ratio. Gear ratio is what? Gear ratio is the ratio of number of teeth on gear, that is capital T, to the number of teeth on pinion, represented by small t. So, mathematically gear ratio capital G is equals to capital T by small t. Here gear ratio is represented by capital G. So, this is gear ratio. Now, the very important term in gear is velocity ratio. Velocity ratio is nothing but it is the ratio of angular velocity of driver omega 1 to the angular velocity of driven omega 2. Now, mathematically velocity ratio is equals to omega 1 by omega 2. Since we know that omega is equals to 2 pi n, so we can have velocity ratio equals to 2 pi n 1 by 2 pi n 2, that becomes equals to n 1 by n 2. And in the next line we know that pi d 1 n 1 is equals to pi d 2 n 2, from which we find d 1 by d 2 is equals to n 2 by n 1. So, finally, we find velocity ratio is equals to n 1 by n 2 is equals to d 2 by d 1 is equals to t 2 by t 1. This is the general expression of velocity ratio, where d 1 and d 2 are the pitch circle diameter of driver and driven, and T1 and T2 are the number of teeth on driver and driven. Now, the train value. Train value is the reverse of the velocity ratio. Since we know that velocity ratio is omega 1 by omega 2, so the train value is mathematically equal to omega 2 by omega 1. Now, types of gear train. There are following 4 types of gear train: simple gear train, compound gear train, reverted gear train, and epicyclic gear train. First of all, we will study simple gear train in detail. Simple gear train has single gear on each shaft. All shaft axis is fixed, and intermediate gears in simple gear train are called idle gears, as they do not affect the final velocity ratio of the gear train. They only controls the direction of rotation and fills the gap between input and output shaft. Now, let us understand the simple gear train with the help of this figure. In this figure, there are 4 gears in this simple gear train: gear 1, 2, 3 and 4. Gear 1 is in mesh with gear 2, gear 2 is in mesh with gear 3 and 3 is in mesh with gear 4. And each gears are on the separate shaft. So, this is known as simple gear train, and each shaft axis are fixed. Only gears are rotating, but shaft axis are fixed. Here gear 1 gives its motion to gear 2 and gear 2 gives its motion to gear 3 and gear 3 gives its motion to gear 4. So, gear 1 is called driver gear, gear 4 is called driven gear, and the gear in between gear 1 and gear 4, that are gear number 2 and gear number 3, are called intermediate gears. Now, let us find the velocity ratio of simple gear train. The velocity ratio of simple gear train can be found out very easily as follows. As we know that velocity ratio is equals to n1 by n2 is equals to t2 by t1. We will apply this equation for a pair of gears, and in this simple gear train we have 3 pair of gears. The first pair is gear 1 with gear 2, the second pair is gear 2 with gear 3 and the third pair is gear 3 with gear 4. So, we will apply that formula in each pair of gears. Let us see how it happens. For a pair of gear 1 and 2, we get velocity ratio equals to n1 by n2, that is equals to t2 by t1. This is the relation number 1, and for the next pair of gear, that is 2 and 3, we get velocity ratio is equals to n2 by n3 equals to t3 by t2, that is the relation number 2. And now, for the third pair of gear, that is between 3 and 4, we get velocity ratio equals to n3 by n4 equals to t4 by t3, that is the relation number 3. Now, multiplying the above 3 relations, we get n1 by n2 into n2 by n3 into n3 by n4, that is equals to t2 by t1 multiplied by t3 by t2 multiplied by t4 by t3. Here finally, we get the velocity ratio as equals to n1 by n4 equals to t4 by t1, that is the relation number 4. This relation number 4 gives the final velocity ratio of simple gear train. We can see in this formula that there is no participation of gear 2 and gear 3 in the calculation of velocity ratio of simple gear train. That is why gear 2 and gear 3 are called idle gear, because there is no participation of the gear 2 and gear 3 in the calculation of velocity ratio of simple gear train. Now, the second one is compound gear train. Compound gear train has multiple gears on each shaft except input and output shaft. All shaft axis is fixed. Now, let us understand this compound gear train with the help of this figure. In this figure, there are 4 gears, gear 1, 2, 3 and 4. Gear 1 is in mesh with gear 2 and gear 3 is in mesh with gear 4. And the most important point in this figure is that gear 2 and gear 3 are on the same shaft. So, this is the compound gear train, and we also we can see that the shaft axes are fixed. So, this is a compound gear train. Now, let us find out the velocity ratio of compound gear train. The velocity ratio of compound gear train can be found out in a similar way by the same formula of velocity ratio, as we know that velocity ratio is equals to n1 by n2 is equals to t2 by t1. And in this compound gear train, we have 2 pair of meshing gears. Gear 1 is in mesh with 2 and gear 3 is in mesh with 4. So, we will apply the formula of velocity ratio on these 2 pair of gears. Let us see how. For first pair of gear 1 and 2, we get velocity ratio is equals to n1 by n2 is equals to t2 by t1, that is relation number 5. And for the next pair of gear, that is 3 and 4, we get velocity ratio equals to n3 by n4, that is equal to t4 by t3. This gives the relation number 6. Now, multiplying the above two relations, we get n1 by n2 into n3 by n4 equals to t2 by t1 into t4 by t3. Since the gear 2 and 3 are on the same shaft, in figure we can see that gear 2 and gear 3 are on the same shaft. So, the speed in RPM of gear 2 and 3 will be same, that is written here, n2 is equals to n3. So, these two terms will be cancelled out from the above relation, and finally, we will get the velocity ratio of compound gear train as equals to n1 by n4 equals to t2 by t1 into t4 by t3. This is the expression number 7. Now, let us try to solve a simple problem based on the compound gear train. This is the problem. In this problem, a compound gear train shown in figure, this is the figure, consists of a compound gears B, C and D, E. In this figure, B and C are the compound gears and D with E forms compound gears. All gears are mounted on parallel shaft. All gears are mounted on parallel shaft. These are the shaft. The motor shaft rotating at 800 RPM is connected to gear A. The motor shaft means power shaft, means the shaft which have power, which is connected with gear A. So, gear A is the driver. 800 RPM is its speed, and the output shaft to the gear F. This is the output shaft which is connected with gear F. Now, the number of teeth on gear A, B, C, D and F are given 24, 56, 30, 80, 32 and 72 respectively. Determine the speed of gear F. We have to find the speed of gear F. Now, let us solve this problem. First of all, we take the given values from this problem. The given values are the speed of gear A, that is equals to 800 rpm, and the number of teeth on each gear is given, that is T A equals to 24, T B equals to 56, T C is equals to 30, T D is given 80, T E is 32, T F is 72, and we have to find speed of gear F in rpm. Since we know that for compound gear train the velocity ratio is equals to N A by N F is equals to T B by T A multiplied by T D by T C multiplied by T F by T E. In this formula we can put the known values and finally we will get the speed of gear F in rpm, that is 57.14 rpm. This is the required answer. Now, the third gear train is reverted gear train. Reverted gear train is that gear train which is similar to a compound gear train having input and output shaft coaxial. Means reverted gear train is nothing but it is simply a compound gear train, but the only difference is that the input shaft and output shaft are coaxial, lies on the same axis. All shaft axis is fixed. And the application of reverted gear train is where there is a less space available. For example, in watches, the reverted gear train is used in watches. Now, let us understand the reverted gear train with the help of figure. In this figure, there are 4 gears: gear 1, gear 2, gear 3 and gear 4. Gear 1 is in mesh with gear 2 and gear 3 is in mesh with gear 4. Gear 2 and 3 are on the same shaft, and the most important thing is that in this gear 1, that is input gear, and this gear 4, that is output gear. These gear shaft axes are coaxial. So, that is why it is a reverted gear train. Now, let us find the velocity ratio of reverted gear train. The velocity ratio of reverted gear train is similar to the compound gear train. Now, let us find, as we know that velocity ratio is equals to N 1 by N 2 is equals to T 2 by T 1, and this formula will be applied for both pair of meshing gears in a reverted gear train. For gear 1 and 2, we get velocity ratio equals to N 1 by N 2 is equals to T 2 by T 1, that gives relation number 8. And for next pair between gears 3 and 4, we get velocity ratio equals to N 3 by N 4 equals to T 4 by T 3, that gives relation number 9. Now, multiplying the above two relations, we get N 1 by N 2 is equals to N 3 by N 4 equals to T 2 by T 1 multiplied by T 4 by T 3. Since we know that 2 and 3 are on the same shaft, in the figure we can see that gear 2 and 3 are on the same shaft. So, they will have same speed, that is n 2 equals to n 3. This will be cancelled out. So, finally, we will get velocity ratio n 1 by n 4 equals to T 2 by T 1 multiplied by T 4 by T 3. This is the final velocity ratio of reverted gear train, that is represented by expression 10. And in the reverted gear train, we can also find one more relation. Let us see the figure of reverted gear train. In this reverted gear train, we can observe that the radius of gear 1 plus radius of gear 2 will be equal to the radius of gear 3 and radius of gear 4. So, this can be written as d 1 by 2 plus d 2 by 2 is equal to d 3 by 2 plus d 4 by 2, where d 1, d 2, d 3, d 4 are the pitch circle diameter or the gear diameter of 1, 2 and 3 and 4 gears. This is represented by expression 11. Now, the last one is epicyclic gear train. The epicyclic gear train is a little different from the previous 3 gear trains. In the epicyclic gear train, the shaft axis is movable, means any shaft axis may move. In the previous 3 gear trains, we have observed that no shaft axis was movable, but in this epicyclic gear train, shaft axis is movable. And application of epicyclic gear train is wristwatches and automatic transmission system of an automobile. Now, let us understand the epicyclic gear train with the help of figure. In this figure, there is a gear 1 that is known as sun gear, as it is in the center position of the gear train. This gear 1 is in mesh with gear 2, that is known as planet gear, and these two gear 1 and 2 are combined together or are kept in mesh together with the help of a carrier 4, that is also known as arm. And also we can see that the gear 2 is in mesh with an internal gear, that is also known as annular gear. This forms an epicyclic gear train. In this epicyclic gear train, the shaft axis of gear 1 is fixed, but the shaft axis of gear 2 is movable because the gear 2 rotates around the gear 1. So, this is the epicyclic gear train. Now, epicyclic gear train problems can be solved by 2 methods. One is relative velocity method and the other is tabular method. In tabular method is very simple, which is discussed in the next problem. Now, quickly let us try to solve this problem based on the epicyclic gear train. This is the problem. An epicyclic gear train consists of an arm and 2 gears A and B having 30 and 40 teeth respectively. The arm rotates about the center of the gear A at a speed of 80 rpm counterclockwise. Determine the speed of the gear B if the gear A is fixed. In this is the figure of a simple epicyclic gear train. In this figure, we have gear A that is in mesh with gear 2. The gear A has 30 teeth, gear B has 40 teeth, and gear A and B are in mesh together with the help of this carrier or arm. Now, the known things are number of teeth on gear A is 30, number of teeth on gear B is 40. Speed of arm is given 80 rpm, that is minus 80 rpm. Here minus indicates that it rotates anti-clockwise direction or counterclockwise direction, and NA speed of gear A is equals to 0. Now, we have to find out the speed of gear B. So, for finding out this value, we will apply the tabular method. In the tabular method, we will we will draw a table. In this table, there are 1, 2, 3, 4 and 5 columns. The first column is for serial number, second column is for action to be taken, the third, fourth, fifth and so on. These columns are used for representing the speed of gears in the epicyclic gear train. The first column represents the speed of gear, the arm N. The speed, the fourth column represents the speed of gear A, and fifth column represents the speed of gear B. Now, there are 4 rows in which the second row, that is that means the serial number 1 gives the action to be taken. The first action is lock the arm and give +1 rpm to any suitable gear. So, we have to take this action. Lock the arm means the arm speed will be 0, and if the and we have to give +1 rpm to any suitable gear. So, we will choose gear A and we will give +1 rpm to this gear, and with the help of formula Na by Nb is equal to Tb by Ta, we will get speed of gear B, that will be minus Ta by Tb. Negative sign indicates that if gear A rotates clockwise, then gear B will rotate anti-clockwise direction. Now, the second row says that multiply by x. So, we will multiply by x. In this 0 multiplied by x becomes 0, 0 1 multiplied by x gives x, and minus Ta by Tb multiplied by x gives minus Ta by Tb x. Now, finally, in the third row we will add y. So, 0 plus y becomes y, x plus y becomes x plus y, and minus Ta by Tb x plus y becomes this minus Ta by Tb x plus y. So, we will see the third row. In the from the third row we can get an arm, means the speed of arm is equals to y, and that is from the third column, and in the fourth column we can get Na is equals to x plus y, and in the fifth column Nb is equals to minus Ta by Tb x plus y. These 3 equations we can get with the help of third row, and now we will put the above given condition in this third in these 3 equations. So, we will finally find y is equals to minus 80, equation number 4 is given, x plus y is equals to 0. So, it gives x is equals to minus y. Now, these 2 values y is equals to minus 80 and x is equals to minus y will be putted in equation number 3, that is Nb is equals to minus Ta by Tb x plus y. So, finally, we will get the speed of gear B, that is equals to minus 140 rpm. Here negative sign indicates the counterclockwise rotation of the gear. That is it. Thank you.